आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
We bring you all a podcast series on STEM popularization, that is, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, the Government of India. Program is produced by Media for Community Foundation.
This is Manjeet. Welcome back to the podcast from the Indo French Center for the Promotion of Advanced Research, also popularly known as CEFIPRA. We continue exploring groundbreaking collaborations between Indian and French scientists. Now let's listen to our great scientists for more information.
Hi, I am Arunan from the Inorganic and Physical Chemistry Department at the Indian Institute of Science. I had established 2 experimental laboratories, one in my department. We built a pulse nozzle Fourier transform microwave spectrometer. This can be used to form molecular complexes at very low temperatures like 2-3 Kelvin. Water dimer, just 2 water molecules sticking together, or even argon and neon, the inert gases, we can form a dimer of them and study them. And also in collaboration with KPJ Reddy of Aerospace Engineering Department, established several shock tubes for high temperature chemical kinetics. I joined in 97. It took 6-7 years to establish both these labs, and we started publishing papers using both these experimental facilities built in-house. A microwave spectrometer in which molecular complexes at very low temperature can be studied, and a shock tube in which molecules could be heated to very high temperature and the reactions could be studied. In 2004, when I was in Kerala for a meeting, I received an email from Professor Bertrand Rouet of University of Rennes. He wanted to collaborate with Indian scientists with the hope of supporting a PhD student from India. They had 2 experimental facilities which were somewhat complementary. They could study molecular complexes formed in a supersonic beam with infrared spectroscopy, and they could do kinetics at very low temperature. We study complexes with microwave spectroscopy and kinetics at high temperature, and they had facilities to study molecular complexes with infrared spectroscopy and kinetics at high temperature. I had not known him before, and thankfully those days internet was there, and we had websites giving details about the work. He had gone through the websites of several institutions and universities in India and chose to write to me. Said, could we use both the microwave spectrometer and the shock tube in the university, in the institute? And we are welcome to use the infrared and high kinetics at low temperature in our place. I was thrilled with this proposal. I had not known him before, so I immediately agreed. That's how our collaboration began. So we submitted a proposal to the CEFIPRA, and CEFIPRA has projects reviewed by both experts in India and France, and our project was supported. Professor Bertrand Rouet contacted me because of some fundamental problems, particularly soot formation in diesel engine. How it is formed was not well understood. There was a mechanism given by a mechanical engineer, Michael Franklau from Berkeley University. It suggested that polycyclic aromatic hydrocarbons could combine together and form soot. So Bertrand Rouet realized that is not possible because they are found by van der Waals forces and they don't survive high temperatures. Now we are looking at molecular complexes formed by van der Waals forces, hydrogen bonding, and he was looking at the kinetics of the complex formation. So our collaboration became really interesting. Benzene dimer is one thing that we had looked at We had shown with microspectroscopy that the dimer is T-shaped with CH by hydrogen bonding. And this dimer is supposed to have another structure in which two benzene could be like this. These are called pi stacking. It's used extensively in the literature, pi-pi interactions. So of course, chemists know that it is not possible because you have electrons in both, they cannot come together. But this was very popular even though there was no experimental evidence for this at all. I realized if we could get the infrared spectrum of these two structures, we would be able to prove or disprove this. Microspectrum needs a dipole moment which the T-shaped structures have. Parallel display structure does not have a dipole moment, but infrared spectroscopy can get the structure. So I had convinced them to do this experiment. Then this experiment was done in run, but we could not get any experimental evidence for the parallel display structure. As of today, there is no experimental evidence, even though everyone uses this. But this the work that we had done with the microspectrometer could be expanded with the infraspectrum. Of course, they had done the benzene plus benzene, benzene dimer kinetic formation. This soot formation we realized could be studied in the shock tube because we can heat the hydrocarbons to high temperatures and get that mechanism. And another colleague of mine, a collaborator, came up with the idea of studying the molecule formation from the early universe. It's the opposite of soot formation. So we put carbon and hydrogen in the shock tube and expose them to high temperature and high pressure. We could show that small hydrocarbons like methane, and even benzene could be formed, and this was published. So our collaboration has been really mutual based on complementary experimental facility, and we could address really applied problems as well as very basic problems, starting from the origin of life to a diesel engine and how it works. Right now, we have a lot more opportunities to continue to work in this field. One thing I can tell you, when you look at the origin of life, we all know amino acids are important. But you don't see amino acids in the interstellar space. How did they come into space, our Earth? One of the possibilities is that they came through some asteroids, some comets. They came in. But how did they get formed? Can we study them? And recently it's been found that silicon could catalyze this molecular formation. So we have plans to look at many of these things using shock tube. We also have plans to study molecular complexes of microwave and infrared spectroscopy to understand the interactions between them. I would just like to add one thing that we did, even though it was not directly related to the CFIPRA project. We study molecular complexes, water being the molecule of life. Hydrogen bonding is very important for its chemical and physical properties. It was well known, hydrogen sulfide is a gas, water is a liquid. But we were interested in understanding how two water molecules and two H2S molecules interact, and we had shown that H2S molecules could also form hydrogen bond. And this is against textbook definitions of hydrogen bond, starting from Linus Pauling and many others. They concluded that only when hydrogen is bonded to oxygen, fluorine and nitrogen, we could have hydrogen bond. We had shown that even when hydrogen is bonded to sulfur or carbon, they could form hydrogen bond. And eventually, I had written to IUPAC and I chaired a task group to change the definition of hydrogen bond. This was accepted by IUPAC in 2011, and our French collaborators have also helped in some of these things. Now the important thing is that we proposed a carbon bond which is similar to hydrogen bond. This was our proposal, it was never known before, and we did some experiments in Salai to look for it, and that helped by the Indo French project. Even though we had been working on both fundamental and applied methods like this, I am really thankful to CFIPRA. CFIPRA is different. It gave support to both the French team and the Indian team. French team could support a student for PhD or a postdoc, Indian team could get some money for some minor equipments, consumables, salary and so on. This was really useful. In fact, this project between myself and Professor Bertrand became possible because Professor Bertrand wanted to support an Indian student and he thought this could help. That student happens to be Balamurugan Sivaraman, who is currently a scientist in PRL. I did not know him at that time. He had done summer project in REN and we applied for this project. Before the project could be funded, Dr. Balamurugan got an offer to do PhD in Open University in UK and he completed this PhD in astrochemistry and he returned and I supported him as an Inspire faculty fellow. The PRL director was visiting our laboratory at that time. He saw what Balamurugan could do. He realized the importance of astrochemistry and he was hired there. But when he had this project, they could support an Indian student and the University of REN team supported an Indian student who is currently a faculty in Vellore Institute of Technology now. He's come back here. Many others were supported like this. So this has really helped. In fact, astrochemistry in India was almost non-existent. And this project has really helped because my French collaborators do work on astrochemistry. Now we have Dr. Balamurugan Sivaraman in PRL, Dr. Vijayanand Chandrasekharan in VIT working on astrochemistry. Dr. Vijayanand was the one who suggested that we should look at the presence of silicon in the hydrocarbon and amino acid formation. But this work was done in collaboration with France. But before we could publish this, some other group has pointed this out. And what's interesting is that our group has the right ideas and we do the right experiments and we've been getting exciting results. I am really thankful to CEFIPRA and I hope CEFIPRA will continue to support this with larger support. Our team visited us. One thing I must tell you, the experimental facilities built here were done with support from other organizations. But CEFIPRA's project support was useful for running expenses and for this collaboration. I hope CEFIPRA can also support larger projects which can lead to establishment of new facilities. Thank you.
This episode is brought to you with the content support from CEFIPRA and the technical support from the Sparrows team. We extend our heartfelt thanks to the Director of CEFIPRA, Professor Nitin Seth and Dr. Payal for their continuous guidance and support. Stay tuned for more episodes and thank you for joining.
आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।